Hello everyone, hope you all are doing well. In this video, we'll discuss the last problem of Leetcode Weekly Contest 311. It's a hard level problem, however relatively easier than the other hard problems that you get into the contest, right? So the problem name is sum of prefix scores of a string. So you are given an array words of size n consisting of non-empty strings. We define the score of a string word as the number of strings word of I such that word is a prefix of words of I. If you are not getting the problem statement, don't worry, I'll explain it in detail. Okay. For example, if words array is a b c c a b, then the score of ab is 2, since ab is a prefix of ab and abc, right? So return an array answer of size n, where answer of I is the sum of scores of every non-empty prefix of words of I. Note that a string is considered as prefix of itself, right? So these are certain examples. We will see how to approach it. It's a traditional try based problem, to be very honest, right? So let's see what the problem is saying. I'll take the first example to explain you. So this is my array, right? This is my array, right? Now what it says, you pick this string and see what are the prefixes of this string. So this string will have a prefix of a, ab and abc, right? These are the three prefixes. Now check that this a is a prefix of how many strings in the original array, right? Of how many? So this is a prefix of this one and this one, so total it's a prefix of 2 strings, right? Check for this one. AB is a prefix of this string and this string. So again, the score of AB will be 2. What about ABC? ABC is a prefix of only this string. So the score is 1. Hence, the score of this string will be 2 plus 2 plus 1, that is 5. Right? This is what the problem is saying. Pick up this string AB. What are the prefixes of AB? It's A and AB. Now just check how many strings have A as prefix. So 1 and 2. So it will be 2. Just check for AB. So this one and this one, so it will be 2. So the score of this string will be 4. Now again pick up BC. So it will be B and BC. Just check how many strings have a prefix of B. So it will be 1 and 2. And now what about BC? It will be 1. So it comes out to be 3. And the last case is B. So only prefix will be B. So how many strings have a prefix of B? This and this. So it will be 2. So hence you will return 5, 4, 3 and 2. This is the problem. This is the problem statement, right? Now let's see how we approach this type of problem. So just see, here we are concerned only about the prefixes, right? So if you are familiar with a try data structure, so how does try look? Try looks like, so we have a root node, let's call it R, and it has 26 nodes representing each of the possible 26 characters, right? Obviously you do not construct all the nodes, but this is the sort of representation. Now that now at the next level, suppose you have A here, B here, dot 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 Z here, so it also has 26 branches and so on. So this is a try data structure, right? This is a very basic thing. If you are not familiar, you can go through any of the tutorials on the net, right? So now what we will do and why we will do that, I'll explain it. So we have certain strings like A, B, C, A, B, B, C and B, right? So just see this one. So the prefixes are A, AB and ABC. So what I can do, suppose I construct the try. This is the root node and I come to A. So if I add this node to the try, so what will happen? I'll have a node A. At the next rail I'll have a node B, and at the next rail I'll have a node C, right? So at every node, what I can do, I also need to count that how many strings have a prefix of A. So while constructing only, what I can do, that I can keep an extra attribute at every node, and that attribute represents that how many strings have passed through it, right? How many strings have passed through it. Like for example, suppose there is a string AD, right? Suppose there was a string AD as well. So now what would have happened when I would have added AD as well in this try? So A was already here, so we would have come to this node and then we would have gone to this node, right? AD would have been there. Now the number of times while adding each and every word we pass through this node, it means that there are strings which have a prefix equal to this, like from root to this path, right? Or in other words, suppose we have CD here, and suppose we have CE here. So if I consider this path, so you can see there are two strings which have or rather three, there are three strings which have ABC as prefix. One is ABC, one is ABCE, and one is ABCD, right? These are the three substrings. So what I can do, when I added ABC, at every node I can keep an attribute that okay, one string has passed to it, one string has passed to it, one string has passed to it. Now when ABE was added, what I can do, I can again add that okay, one more string has passed to it, one more string has passed to it, one more, and then here I get 1. Now when ABD was added, then again I can increment it, so it becomes 3, it becomes 3, it becomes 3, and it becomes 1. Now if someone asks me that for ABC, tell me the number of strings which have a prefix of AB, what I can do, I can simply traverse. First I need to calculate the score. So here I need to calculate the score of A, AB and ABC. How I'll calculate the score of A? It will be dependent that how many strings have passed through A, right, while constructing. So I go to A and I see the score is 3. I add it to my answer. Now I go to AB. How I go to AB? After A I move to B. So I see number of strings that have passed through B as well equals to 3. So the score of AB is 3. I add it to my answer. So it becomes 3 plus 3. Because if B equals to 3, that means there are at least 3 strings in my input which have a prefix of AB, right? Now I pass ABC. So I move from B to C. Again I find 3. So it becomes 3. So my total score will be 3 plus 3 plus 3, right? So this is how I will calculate it. So I'll construct the trie. While constructing the trie, I'll be keeping an extra attribute. So while adding the nodes only, I'll be keep on incrementing this count. And in the second phase, when I want to compute the score, I will traverse that trie and just add these strings and I'll be good to go. I would say relatively much more easier problem, much more easier fourth problem as you get in the other contest. But yeah, again, for the folks who are not familiar, a new concept to learn, right? So yeah, let's start from line number 38. I've calculated what are the number of elements I have. I have constructed an output array answer, and on line number 41 you can see I'm inserting the words in my trie, right? So let's go to this. So let's first go to line number 3. My trie has nodes and each node has 3 things, whether it's a terminal node or not. However, that is not required here, I know, but this was a traditional trie code that I wrote. So it's a terminal node or not. So by default it will be false. Like for example, if I have a string AB, so in that case B will be a terminal node. However, that is not required here. I totally agree. On the next line we have children, so we can have 26 possible values for the 26 characters, and we have a word count that I told, an extra attribute, right? These are the 3 things every node will have. On line number 9 I have constructed the root node. Now I was calling the insert function. So just see what is happening on line number 12. I am passing a word, I am calculating the length of the word, and I am starting from the root node. On line number 14, just see that. Now I am traversing each and every character in that particular word. So index equals to word.char at minus a, because those are numbered from 0 to 25, right? It's an array of 26 characters, so those are numbered from 0 to 25. I check whether my current node has that child or not. So if current dot children index equals null, that means till now this particular character or till now we haven't explored this path. So what do? We construct a new node at that path. So current node dot children of index equals to new node. Now what you do? You just move one step down. Like for example, initially you were at root node. Now you want to traverse A, so you move now to A, right? It's a tree traversal, right? So current node equals to current dot children of that particular index. Also current node dot word count plus plus. This is an additional thing that I have done so that I know that how many strings are passing through this path, right? This will be useful in the second function that I call, right? And current node dot is terminal equals to true. That is not required here, but again I have added it, right? So this is the stuff that we do while inserting it. On line number 43, 44, you just see that for each and every word, answer of I equals to traverse and get score. I call this function with words of I. Now on line number 26, this is the function. I am doing the exactly same stuff. Calculate the length of the word, start from the root node. Initially the score is 0. What you do? Now you explore the tree, you traverse the tree. So index equals to word.char at minus a. So you move to that you move to that particular child node. So current node equals to current node dot children of index. Now you increment the score. Score plus equals to current node dot word count, because this word count represents that how many strings have passed to this path, and that means how many strings have a prefix, uh, have the current path as the prefix, right? So we'll increment the score. Finally, we return the score. On line number 46, we return our answer. So yeah, this was the code. You can practice try with some other problems if you want. I can probably provide you some more problems. Do mention that in the comments. I can provide some traditional try problems, and we will be good to go. So if you learn something new from this video, do support it by liking this video. Do subscribe to the channel. If you have any queries, then please mention that into the comments. I'll be more than happy to revert on each one of them. If you want to connect with me, you can connect with me on LinkedIn. The link is mentioned into the comments. I'll be more than happy to do that as well. And yeah, take care. Bye bye.